everyone, we're just going to do a little bit of revision on index laws, just so there's no confusion on some of the laws, because I think we're mixing a few of them up, particularly the power of the power and the multiplication rule. So, first law, our multiplication law. Now remember, we can only use our index laws when we have the same base. So that means that the big number at the bottom has to be the same for each one. So we absolutely need the same base. So with our multiplication rule, that rule says that if you have two numbers with the same base, so I'm going to say this is 2 to the power of 3, and we're multiplying it by 2 to the power of, let's pick a random number, 8. That means that we add our powers, because it's the same thing as if you were going, so 2 to the power of 3, I'm going to draw this one with my green. So 2 to the power of 3 means 2 times 2 times 2, and then 2 to the power of 8, and I'm regretting picking 8, so that was our green one, is going to be times 2 times 2, 3, 4, 5, 6, 7, 8, and we're multiplying all of those ones there. So if we were expanding them out, that's what we would do. You don't have to do that when you're solving these. This is just to show you. So we end up with 2 to the power of 3 plus 8, because if you notice, if we count up how many times we're multiplying 2, we get 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we end up with 2 to the power of 3 plus 8, which is 2 to the power of 10. Now that's 3 lines of working out. You don't have to show this line. This is just me putting this here. But in a question like this, you do need to show these 2 lines of working out. Let's try another one. So we had, let's pick, we can even pick a letter. So let's pick A to the power of 5 times, and notice that I'm timesing, not adding. We can't do this when we're adding 2 numbers, even if they have the same base. A to the power of 15. That's the same. I'm not going to write this one out because that would be too many A's, but it's the same as if we went A to the power of 5 plus 15, which is A to the power of 20. So that's adding. I feel like we're all getting this one pretty well. It's just when we've thrown the other index laws in that sometimes there can be a little bit of just some little tiny mistakes in there. So that's our first index law. The one that we're getting mixed up with is when we go to this power of a power rule. And I know that I'm skipping a few index laws in between. A power. Now the textbook, sorry, I'll bring that down so you can see. The textbook calls this raising powers rule. It's the same thing. There's many different names for it. It's the power of a power rule or the raising powers rule. And this says that when we'll start with one in a bracket. So for example, if I'm going to use my 2 again, if I had 2 to the power of 3 and then inside that bracket's 2 to the power of 3, outside the bracket I've raised it to another power. So let's say 5. This is the same. If I was to expand it, it would be the same as I'm going 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 5 times 2 to the power of 3. Notice that I'm expanding, and we know that when we have them multiplying like this, we're adding them together. But I don't want you to get fooled that that means that we add these 2 numbers together, which was a mistake that was happening a little bit in the Google form yesterday. So when we have this, we've got this 5 times. So if I added them together, I'd have 2 to the power of 8, but we've actually got 3 plus 3 plus 3 plus 3 plus 3 5 times, which is 2 to the power of 3 times 5. And that's where we're running into some issues a little bit. So it equals 2 to the power of 15, not 2 to the power of 8. Let's try another example. So for example, if we had, let's pick 6 to the power of 8. Oh my goodness, I almost wrote 7. That would have been crazy. To the power of another power, let's pick 10. And then if we wanted to be even crazier, we could raise that to another power. And let's put that as 2. And so if we were to expand that out, we'd just start with our inside one first. So we'd go 6 to the power of 8 times 10. And then that whole thing's going to get raised to 2. Which would be 6 to the power of 80 squared. And then again, we have to go 6 to the power of 80 times 2, or 6 to the power of 160. So remember, when there's brackets involved, we're multiplying. Whereas when we've just got multiplication, there's no brackets involved. That's when we add together. Let's look at the division rule very quickly, because that is the reverse of the multiplication rule. So the division rule, which this one most people were really good with in the, not that we had in the Google form, but in the other things that we've done in class. This means that when you have two things and you're dividing them, so let's go 4 to the power of 8 divided by 4 to the power of 6. This would be, and again, I'm going to spell it out. You don't have to put this line of working out. This would be the same as if I had 4 times 4 times 4 times 4 times 4, 8 times. 6, 7, 8. I had to count them. Oh my goodness. If we had that and we were dividing it, and remember, a fraction is just like a dividing symbol. 4 times 4, 6 times. Now we know when we have a fraction that any number divided by itself, so like for ours, any number divided by itself just equals 1. So we say we cancel it out, but really, which we are cancelling them out, but really what we're saying is that we're like, this is 1 times, and then these two ones on the end don't have a partner to cancel out. So this cancels out, cancels out, cancels out, cancels out, cancels out, cancels out, because 4 divided by 4 is 1. Anything divided by itself is 1. So we end up with just 4 times 4 on the top, which we know is 16. You could write it as 4 to the power of 2 though. 4 to the power of 2. Now, if I wasn't going to spell, do this extended thing, which I'm not expecting you to do for every question, but if that helps you, you can. If I wasn't going to spell it out like that, I would just subtract. So let's use our same example so that you can see how to set it out. 4 to the power of 8 divided by 4 to the power of 6. You could just set it out like this. 4 to the power of 8 minus 6, which equals 4 to the power of 2, which is what we had up here. Anyway, that's how you would set out the division rule. Even if your question is like this, if you had 2 to the power of 10 divided by 2 to the power of 5, that would be the same as 2 to the power of 10 minus 5. Remember, it's not 10 divided by 5. We're minusing here. The 2's are what's getting divided. 2 to the power of 5 is our final one there. And then the last index law that we looked at was the power of 0. So, which is called the zero power law, which technically for some reason is the third index law. I'm not sure why it's third, but it's the zero power rule. And it sounds very simple in that anything to the power of 0 is 1 except for 0. Zero to the power of 0, because that's undefined. We call that undefined because that means that because we can't divide by 0 at all. That's like just a fundamental mathematical rule. We can't divide by 0, so we end up saying that we can't even raise 0 to the power of 0 because it's undefined. And the reason we end up with it equaling 1 is similar to that division rule before. Let's say we had 2 to the power of 4 divided by 2 to the power of 4. If we wrote that up, we would have 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2. So I've expanded it out. These two equal 1. These two cancel out. These two cancel out. These two cancel out. And we end up with 1 divided by 1, which is 1. And that's the reason that the 0 divided by 0 doesn't work, because we can't have 0 divided by 0. It doesn't work. Even though, in theory, we could have 1. It doesn't, because we can't divide by 0. I'm going to show you a better way of doing that next lesson when I get back, because it does look really cool in a graph. But that's our 0 power rule, and we're running into issues when we have some problem solving. So for example, you might have a question like this, where it's like 3 to the power of 2 times 4 to the power of 5, and that whole thing to the power of 0. And then we might get tempted to start adding, which is what happened, is a very common mistake that keeps happening, because we know that if we, and they're not even the same base, so you couldn't add them anyway, but if we have anything to the power of 0, whatever is raised to the power of 0 becomes 1. So this answer is 1. But if you had a question where there's powers of zeros involved in multiple things, like let's say 3 to the power of 0 times 2 to the power of 0 minus 18 to the power of 0, this isn't just 1. Even though we're raising to the power of 1, we've actually got 3 to the power of 0 is 1 times 2 to the power of 0 is 1 minus 18 to the power of 0 is 1. So we end up with 1 times 1, which is 1, minus 1, which ends up being 0. And it can happen the other way if we're adding them as well. So you might have something a little bit more complicated. We might even do some things with algebra here. So you might have a plus b, all of that to the power of 0, plus 21 to the power of 0. And in this case, remember, anything to the power of 0 is 1. So we've got 1 plus 1, because 21 to the power of 0 is 1. So in this case, we end up with 2. And that's the mistakes we're making. So it's only what's raised to the power of 0 is 1. It's not 1 overall. We have to work out which ones are equaling 1. We're going to look at some revision questions today, and then when I'm back next lesson, we're going to look at the final index laws. Good luck. Hope you go well today.